In lesson 4, we're talking about properties of similar polygons, and we're on page 543, but we're actually moving to page 546. So I just want to do one of these problems. We talked about how to find if two figures are similar or not. Regular polygons are the same as triangles, so to find out if they're similar or not, you're dividing the second one, the side length, by the corresponding side length. So this one we would divide 12 by 4, and if we get 3, that's our scale factor for this side. But if we do 13 divided by 5, these two correspond, and because 13 divided by 5 is not also 3, then these are not similar. And same thing on this one, the 6 corresponds with the 8, and if we did 6 divided by 8, and then this 6 over here corresponds to the other 8, so 6 divided by 8 again, 7.5 divided by 10, and 13.5 divided by 18. We would get the same number for each division or each ratio, and so this one is, these two are similar. But sometimes there's a missing side length, and we have to use the similarity of the triangles to help us tell what the side length that's missing is. So first we have to see, these tell us that the two triangles are similar already. And so we know that since this has one arc and this has one arc, and this has 3 and this one has 3, that 1 to 3 is 1 to 3. So this 8 corresponds to the 10. And so when we divide, if we divide 8 by 10, and then the next one we would divide 4 is 1 to 2. 1 to 2 goes with here at 5. So the next one would be 4 divided by 5. And then the 4.8 goes with the x, so we're not going to worry about that one just yet. But these will give us our scale factor. And technically, because we know they're similar, we only have to do one side length. We can use the 8 divided by 10, or we can use the 4 divided by 5. They're both going to give us the same answer here. So if we do 8 divided by 10, we would get 0.8. And if we do 4 divided by 5, we would also get 0.8. So 0.8 or 0.8 is our scale factor. And we can see that because the shape gets smaller, it goes from big to small, we know that our scale factor needs to be less than 1 or between 0 and 1. And 0.8 is between 0 and 1. So in order to get the smaller triangle, if we multiply 5 by 0.8, we should get the corresponding side length, and we do. 5 multiplied by 0.8 would give us 4. So we can do the same thing to find any missing sides. Now, our missing side is on the original, and if your missing side is on the original, you would take the image and divide the corresponding side by the scale factor, because when we go from the original to the new one, we multiply by the scale factor. So when we go backwards from the image to the original, we would have to divide by the scale factor. Okay, so to find this side length, our original is 4.8. So 4.8. Is the original, and we're going to divide that by 0.8. And I don't actually know what that is, so let me find my calculator very quickly. Sorry about that. Okay, so when I type in 4.8 divided by 0.8, I get 6. Okay, so that means that x is equal to 6. Now, let me check and make sure though. The image should be smaller than the original number. So I can see that the 6 is bigger than 4.8, and so I'm probably correct with my answer. So 6 is what x equals. And on this particular problem, they also wanted to know what transformations are used. So I can see that the one angle is here and the one angle is over here on this one. So if I rotate this triangle 180 degrees, it's going to match up and then I do a dilation. So the transformations are a rotation, 180 degrees, and then a dilation would make it a different size. A dilation by a scale factor of 0.8. And then I'm finished.